So hi Merlijn, good morning.
Good morning, Simon. I'm Merlijn Chardon. I'm a mechanical engineer with a focus on sustainable energy, sustainable technology.
Okay, thanks. And so during the past months you participated to the AMable project. Could you please explain a little bit more about the application you were working on?
Yeah, well, we were working on a component for a novel dryer, industrial dryer, that is supposed to dry biomass, wet biomass, efficiently using residual heat. With the current drying methods, it's economically not viable to dry the wet biomass, the agricultural residuals, economically efficiently. Using our novel technology, we managed to do this drying process more efficiently and also using residual heat, reducing the cost of the drying process dramatically. By using 3D printed parts, we managed to not only make the whole equipment smarter, but we also bring the cost down compared to conventional production methods. And the geometries would be hardly feasible to produce with conventional manufacturing methods. And using 3D printing, we can not only achieve these geometries, but we can also do it much more affordable than by, for instance, milling or lathing the components.
Okay, so I understood well that additive manufacturing plays a big role in your developments. What did you expect from the technology?
With additive manufacturing, you have hardly any waste and you can iterate really fast compared to these regular technologies. Reducing the cost of prototyping, but also reducing the time to market dramatically compared to these conventional methods.
Okay, and during the project you tried out additive manufacturing by yourself. Did everything went as expected?
Overall, the project went pretty much as planned. There were some parts that proved a bit more challenging. For instance, the conditions under which we load the filaments are not typical for 3D printing filaments. They have to withstand high temperatures and high humidities at the same time. And you typically don't find such specifications on the websites of or data sheets of suppliers. The help of the AMable services was really useful in that process of finding out how to print these large parts with engineering grade filaments. And also several issues turned up when we increased the nozzle size, which is also not typically done in the 3D printing community. It turned out that some components simply can't stand the forces that come with a larger nozzle.
Okay, interesting. You already mentioned the AMable services. Could you explain a little bit more about which services you used within the project and why you used them?
Yeah, the first service we used was designed for additive manufacturing, and that was really helpful, especially since the engineering grade filaments, they tend to warp. Considering the pretty much ring-shaped objects that we were printing, large rings of about 30 centimeters in diameter, when they shrink and warp, they will easily lift off the print bed, ruining your print. Well, we got a lot of help in reducing the warping, the tendency to warp, optimizing the printer setup. And the second service that we chose was industrialization of additive manufacturing, and it was chosen to help us on the important cost aspect. So we got a lot of insights on how to keep those costs acceptable and how to optimize the use of the printer, for instance. To ensure that we can still meet the targets of the economic cost of producing these 3D printed parts.
So, and how did the AMable support help you with this?
Well, they really helped us on the challenging road towards reliably and affordably printing of the engineering grade filaments. If we had to do it all on our own, well, of course, we still had to find a lot of stuff out, but the idea that you had this these services standing behind you, assisting, thinking along on the challenges that we had to overcome was really helpful, especially since we quickly found out that the online 3D printing community falls short on these novel challenges. The knowledge, just the idea that we had several 3D printing experts on standby to help us out, thinking along both on the technology and economic aspects of the 3D printing.
So now we are coming close to the end of the project. Could you give us an idea on when your product will become available on the market?
Yeah, the 3D printed parts, they are pretty much done, but the machines that we're talking about are much more than just 3D printed parts. So we will have at least a year of intensive testing and further prototyping on the whole system assembly. And we hope to be on the market in the first half of 2022. And a even larger model that is expected to reach market in summer 2023.
Okay, so during the AMable project, I imagine you increased your knowledge about additive technologies a lot. Do you have plans now to use this technology for other parts in the system or even other applications in the future?
We are currently also working on a alternative to the conventional air conditioning systems that is based on evaporation. And especially during the prototyping phase, we are continuously using the 3D printer.
Okay. So if you look back to the project now, how would you describe your experience with the AMable project?
The AMable project has been an interesting and really instructive project that helped us to kickstart the innovative dryer.
Okay, that's very nice to hear. Thank you for the nice story, Marlene, and I wish you all the best in with the future projects.
Thank you. Thank you all for all the help.